Hello there, and welcome in my next episode on my STM32 programming tutorial series. Today, I want to show you how to write your own libraries for GPIO, external interrupt, and ADC setup. The reason why I do this video is obvious. You don't want to burn yourself out by writing the same code again and again. That's why we use libraries. Let's start. Already you can see that I have opened all the three projects: GPIO tutorial, tutorial ADC, and tutorial external interrupt. As you can see, I left the code untouched. For here is the same. And here is GPIO. I will start with GPIO, and also I would like to make a delay header file, because you can see that this delay function and this 60 handler repeats itself in multiple cases. For example, in tutorial ADC is the same. So in order to save some lines in our main.c file, I will also make a library for a delay function. I will start with the delay. Let's go to File, New, Header File. Over here, I will change the directory from source to includes. And let's name it, for example, delay.h. And let's use C header template. Okay, and here is our template. This if not defined means that I can move this header file into multiple files in the same project. And this if not defined means that if it has not been defined, this header file, it will actually load the header file. Because if you wouldn't have put this if not defined and if, every time when, for example, you can put a header file into another header file, and therefore you can have delay function header file in like 6 cases, and each time it would have to load itself. So this is more practical and actually the only way how to usefully do it. Let's start copying my code. GPIO. And what do we need? We need this section, Control X, Control V, but also we need this unsigned integer. Basically, I can take the prototype also, put it over here. Yeah, let's put it over there. MCU clock we can leave in our main.c because we need to set it up every time. For example, if we want to use different clock speed. And system config I will also leave over there. So we must not forget that. Otherwise, I think it's all. And now if I build it, it will throw several errors. Yes, it throws the errors that delay is not, undefined reference to delay. So to include the header file, now we just can do private include delay and I think it's delay functions.h. Right. And let's build right now. 0 error, 0 warnings. Everything is perfect. We are ready to move on. Now let's start with header file for GPIO. Now it starts to get a little bit complicated, but still it's more or less easy. New, oh no, I missed. New header file, and again let's change this to includes, and let's make it GPIO.h. Yes. So this is it. Now, basically I want to make this header file to automatically set up pin for output, input, and analog mode for all the ports and all the pins. The pins are from 0 to 15, and the ports are port A, B, C, D, E, F. And also I would like to make a function for setting and resetting the certain pins, because this is very hard to read. So let's go like, let's copy this, cut GPIO.h, and this actually sets the pins as the output. So let's call this function. It will return a void. It will be GPIO. It is better to name your functions in header files as directly as possible. So the first part of name of the function should be its GPIO or its ADC or its external interrupt. Should name the function, for example, setup GPIO. No, GPIO setup, this way. So GPIO output setup. And actually, now I will do a little bit of magic, and I will explain to it in a moment. GPIO type def pointer port and like this. Let's explain the magic. GPIO type def, what's that? Let's take a look. Open declaration. And you can see it's a struct. So basically, we have, for example, port GPIO-A, and we must create the integers for it. So therefore, we need to define that the GPIO-A is actually a pointer on this structure, which includes all the registers. And here is the pointer. And unsigned short pin, it's simple, it's the name of the pin. And to define the port and pin, I will show you to do it in the main.c. So we know that we have port C, and it's pin 8 and pin 9. So Pravi defines LED1 port GPIO C, define LED2 port GPIO C also. Now let's define LED1 pin, it's I think 8, and define LED2 pin 9. Over here we can see that GPIO-C is already defined as a pointer, the GPIO type def, which is struct. So the system header file for the microcontroller already knows which structs to create. Now we define the names of our ports and pin numbers. Let's continue in our header file. We know that there are multiple ports, so therefore we need to set up the peripheral clock for it, but I don't want to set up the peripheral clock for all of them. I want to set up the peripheral clock specifically for the used GPIO port. For that, I will actually need to do one more define. Port state on and port state off. I will actually write it by caps lock. So like this, and on is 1 and off is 0. And now I will do multiple variables. Port A state, and it's equal initially this. I will basically copy it. And we do port B state, port C state, port D, port E, port F. And all of them are off, all of them are 0. Now let's make the if statement. If port is equal to GPIO A and port A state is equal to port state off, which means it's in a default state. If this statement is true, you will set up the RCC for the port A. But for example, we can have multiple pins on the same port, and I don't want to set up the clock 10 times for the same peripheral clock. It is like it is not useful. So therefore, I will write port A state, and I will assign value to it. Port state on. Therefore, we will never again enter this. This condition will never be true, and we will never enter the if statement. Therefore, we will set up the ADC, the GPIO clock only once. And now we have to do it multiple times. Once, 3 times, 4 times, 5 times, 6 times. I will fix this alignment so it's nice. You can see that the code starts to get a little bit big, but it's no problem, because when you hide it inside the header file, you actually don't need to look at it. You are not that afraid to work with it. DEF, port B, and you can actually see it is quite fast. C, E, F. If you have multiple ports, do it for multiple ports. And over here I will write B, C, D, E, F. Over here is port A, so port B, C, F. Is it everything? No, 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 no. This looks okay. Actually, I have GP. I've written some nonsense. GPIO. Yeah, there is a nonsense. I will fix it later. Right now. Okay, now it's correct. Now let's set up the individual registers. We need to make it automatically, so we need to null. Yeah, I know. We are nulling. We need to use 1 for pin multiplied by 2 and also +1. To make more clear what I've done, let's look to the reference manual. I've opened my reference manual. Let's go to the GPIO registers and let's go right to the modder. And as you can see, what I've just done, I will switch to the IDE. For example, let's enter, we have port A and pin 0. We are nulling at first the modder register, so we are setting 1, which will be then negated, to locate to position pin multiplied by 2. It is 0 multiplied by 2, therefore it is 0 pin and we are setting 0. The second position, pin multiplied by 2, it's 0, but +1, we are sending 0 to position 1. For example, if we have pin 10, we are setting 0 position 10 multiplied by 2, that's 20, and 21. Let's look. 20, 21, and it's moved to 10. I hope I explain to you how this bit shifting operation works. But if you have some problem with it, you will catch up later, because this is the fastest and most efficient way how to do it without using those macros. You can write zeros and ones directly to certain positions. Now we need to write 1 to the lower bit. So always the 4, 6, 8, 0, 2, etc. Therefore, we can just copy basically this part. And this will set up the module register the way we want. So again, we want to set up, for example, pin 9 as an output. We will shift 1 to position 18. Position 18, and it's pin 9, model 9. Works. There is some sort of syntax error. Oh wait, I've done... Now it's fixed. And it's okay. Let's continue. We must null these 3 registers. Let's take a look how they look. O-Typer has only 16 positions. O-Speeder has 32. We'll put down 32. Basically, we can copy this right inside here and inside here. I actually have one problem because this pin should be with small p. Sorry about that, everybody fix it. Now it's correct. And over here we know that the O-typer has only 16 positions. So basically we just delete. And we keep it simple like this. In turn, O-typer turn. This is as simple as it can be. Now let's start copy and pasting. And this is output. So this one will be input. This is analog pot. Let's make it like this. And we know that for input, we just need motor to be nulled. So we delete this part where we set motor for output, and that's basically all we can do. And with analog, we actually need to do exactly opposite thing. We need to set both pins to 1, so basically we can delete this row, and I'll actually show you one more trick. I will do. You can do it like this. You can write bits also like this, that 0B11, which means in binary 1 1. And to explain it to you, basically the bits are set up in the increasing value. So basically we have, for example, pin 5 multiplied by 2, and we are setting for 1. So it's pin 5 multiplied by 2, motor 5, and this will be set to 1, and this will be set to 1. Basically, it works like this, that you will move basically 0 from here. From position 0, you will move your virtual 0 over here, and this is your new start, and every bit you write, it will increase to the left to the more significant bits. Now let's write the bit set and reset function. For this, let's go back to our GPIO tutorial. And over here we see that I will firstly cut it like this. And I will do pin set, GPIO pin set. And I will copy this condition, or these two tables. Over here will be port, and over here will be pin. And to reset, this is the most simple way. The reason why I use bit reset register is that it has 16 bits, And BSRR has the setting bits, the lower 16. Because if I would use the reset bit set reset register, BSRR, or resetting register, basically I would have to do thing like this, that basically we will start from the position 16 and above. But when we have in the that reset register, we don't need to use bit set reset register. So now let's review our code with the new library. GPIO.h. And now I will just actually copy all the function prototypes on the top of the header file, so you can then just copy paste them. And if you want to see what they do, you will just scroll a little bit lower and you will figure it out. This is very useful. Okay. And we are setting basically only output. And let's redo it. LED1 port. Here. Here. LED1 pin. Here and here. Rewrite this. I will copy this set. And I will do it a little bit differently, that I will set one LED and reset another, so they will be switching. They will be alternating between each other. Again, LED1 port, LED1 port. Over here. Here we will reset LED2. Over here I will set it up. Okay, and so here we have included both header files. Here we have this. And that's all. We can see that the code is much more shorter. For setting and resetting, we actually use a function, and it's a little bit more readable for average user. Okay, I will record your results, and in the next part I will continue with making a header file for external interrupt initialization. With the GPIO library finally done, and with the delay library done, we can close GPIO tutorial. And let's start with external interrupts. Let's take a look. So we have output for LEDs, input button, and over here for external interrupt, we have to initialize the channel. we need to set falling trigger and unmask the register, unmask the pin in the register. And then we have to, in nested vector interrupt controller, set priority and enable interrupt request. So we already sorted this, this, and this. And we have to start with configuration of the channel. So new header file includes, let's make it like this, because I will only make falling edge because I'm not using rising edge on any project, so for me it's useless. And let's start copy pasting. We must actually again define the pins and ports for now not only LEDs, but also for button Now let's start with the very same thing. I will actually copy this part. This will be the same. EXTI channel setup, let's say. That's good. And let's look into the reference manual. To the external interrupt setup register, configuration register. We know that this register has 4 parts. Basically, it's 4 registers, each one for 4 channels. And I actually start writing and I will explain in just a moment. Over here, pin must be smaller than 4. Now I will make it first skeleton. So here we are done with our skeleton. And basically what I'm doing, if a pin is lower than 4, which means 0, 1, 2, 3, 0, 1, 2, 3, then in the first element of the array of these registers, set port A and then left shift it on the position of the current pin. Pin is correctly 0, so then it will be 0, 1, 2, 3. But if there will be pin 3, 3 times 4 is 12. And it's 12, 13, 14, 15. Okay. I hope it is clear. Now again, let's just copy paste. And here we will just rewrite port B, port C, port D, port E, port F. And now let's do it for four times. Okay. Over here, we will rewrite this. And now, next thing we must do is to change this macro, because this is for the first external interrupt controller. We must pick the second one. This one. And then over here, -4. It is because the value of the pin would be otherwise bigger by 4 than the size of the register itself. Okay, let's take a look again and pick another value. Also, you can write the bits there yourself, but you don't have to remember it. If you remember where the where to find this information. You don't have to remember the exact values. I will move again. Over here we will put -8. And so on. -12. The next thing we must do is that we must set up the mask register and falling, set up the falling edge. This will be much more simpler. B. Be just like this. This is as simple as it can be. And we are done. Now we must enable it in a nested vector interrupt controller. So and again, we just only need a pin now because the channel is configured to a certain port. Now we just work with the pin. And this will be more complicated because we need to set up the proper nested vector interrupt, just interrupt request vectors, right? Over here we can see 0, 1, 2, 3, 4, etc., etc. So we have to do it for the each and every interrupt vector. So let's go. Let's start from the bottom. If pin is equal to 0, just like that. I think this is enough because there is 1, 2, 3, 4, and then there is 9 to 5. So bigger than 4 is, and smaller than 10. So it's 9 to 5, small, like this. Now let's just copy the names. The reason why I'm copying it is because you can see it's not named the same. Or this is a touch screen. The T stands for touch screen. I think it's written over there. Touch sense controller interrupt, right? Maybe I will show you how to work with that in some later videos. and we need one more. Bigger than 9, smaller than 16. And it's this one. I will copy the function prototypes at the top again, so you can just copy paste it and not to think about what's inside. Let's save. Include, and now calling edge, but we need also library delay and GPIO. We know that GPIO.h is in GPIO tutorial folder, and I will copy both GPIO and delay function, just like that. And let's include it. I actually think that I don't need I actually do not need a delay in this program. I need LED button. Copy this. Button pin. Button pin. Button pin. And here is button port. And also let's copy the input setup. Let's set it as an output the LEDs. Oh, you actually delete these commands. Over here, let's copy inset and reset. And again, I will do this alternating between the on and off state, so we can see that the LEDs will be alternating between on and off. So I will set LAD1 and reset LAD2. And here I will just switch one with LAD1 with LAD2. Also, let's not forget, if you change the button, pin or port, especially the pin, you must use a different handler and a different pin, a different bit in a pending register. This is a LED toggle function. I see that the code is much smaller and more easy to read. Let's build. 0 warnings, 0 errors. I will upload the code and again I will record the results. The last part of this tutorial will be the ADC setup library. At first I will again do some defines. Can already copy our delay function header. Therefore, we can delete this variable, this prototype, go down here and delete this part. Then we can copy the GPIO.h. We can over here GPIO output selection. We can see port. So let's go with let's create new array to include, and it will be ADC1 configuration.h. And we see the first obstacle. We must define set up the peripheral clock. So let's Control X, Control V, and over here we can see that I want to this library to use only this clock mode, which means that CK mode will be 00. Therefore, we will use the maximum frequency of the clock, and we have this divider, which has quite a lot of values. So ADC1 clock configuration and scalar. Let's name it like this. CK mode will still stay the same, but I want to change the divider or the prescaler, which would be set in the moment when we will call the function. For this, I will use the switch case. I will I don't know how many of them there are. So there can be so this one we will not use, we will use 1, 2, 3, 4, 6, 8, 10, 12, 16, 32, 46, 28, 256, and default. Let's fix the spacing. Missed. Let's go. Control X. Over here for the case 2. We know that we will use this micro. For case 1, divide 1. Four, 6, 8, 10, 12, 16, 32, 46, 28, 256, and anything else. If your default state is basically if not a single case is met, this will be executed. So for example, I want in default state to use the largest value 256, and that's about it. and then we have to enable the peripheral. That's okay. So let's make this prototype. Control C, Control V. And I want value 2 to make it same. Next, ADC calibration. Calibration is always more or less the same. Depends on type of microcontroller. For example, STM32F0, they don't have this voltage regulator, and they have, for example, a different clock source. They have a 14 megahertz internal oscillator. So this library is useful only for F3 and F4 MCUs from STM32 series. Basically, there is nothing to change. We can just copy paste it, make another function, ADC1 calibration, nothing inside, just a void. And over here we have a delay function. And this is the case, what about I've been talking before, that we must include into this header file delay header file, so we can use it inside. So at first I will include it. Okay. This. Configuration. As I am looking at it, basically this is like 80 or 90% of the times when I use ADC, I use it this way. So I'm using some sort of timer as a trigger. I never usually use continuous conversion mode. I use 12-bit resolution because that's one of the reasons why I moved to STM32 controllers anyway. And if I would like to change something in it, I would actually have to go to the header file and change it manually. I will not make it as much interactive because it would take a lot of time. And I think for the basics, know how to create your own libraries, this is enough. So I will just cut and paste it. Maybe I will just put the interrupt outside and make another function just for interrupt enable. So it would be an obvious that be using interrupt IRQ enable like this. Yeah, that's probably it. What's next for us? Is to do the ADC enable. Again, I will just cut and paste it to make a function out of it. just like that. And this library is set that in the configuration we have chosen the timer 15 as a primary trigger source for the ADC interrupt to occur to start the conversion. So we can also cut and paste the timer 15 configuration. Again, if I do any projects, I 90% of the time use this timer 15 because, as I said, like it's not some sort of special function timer. It's I use it just as a ticker. So for reasons for me unknown, the OBS stopped recording the audio, so I will backwards a little bit and explain what I've done once more. So basically, inside our tutorial ADC, I've copy-pasted the header file names. Over here I made one mistake that I had to LAD 1. I don't know if it was a port or pin, so fix it please if you've done it after me. I cut and pasted the two variables from the main.c to the header file because these two will be always used when I will use this library, so that's why I've put it inside. Voltage value I've let in there. I added a LAD variable. I will explain to you later. Over here I made the functions. I think like it stopped recording at the timer 15. I just cut and pasted, and then I cut and pasted ADC start and made a function out of it and call it over here. This I kept completely the same. And I change over here, I had a LAD bitwise toggle, and I changed it for this function. You can see what it does. It simply toggles an LADs. White is on, the orange is off, then orange is on, and white is off. It alternates. I think that's it. I will just show it in the debugger right now that we are measuring values. Let's place run. And on the right, you can see live values from the converter. I will turn a trim port for you. You can see that the value increases right now, all the way up to 3.3 volts or 4040, 90, 94, 92. It jumps. Now I turn all the way down. And again, if you want a faster refresh rate, inside the header file, you will just rewrite the configuration of the timer. If you want a different resolution, you will switch a resolution inside the configuration of the ADC. What else you would want to do? Maybe change a calibration factor. But there is not like much to do. Of course, you can change your prescaler. Over here in calibration, basically there is nothing to change. This is always the same. Yes, and if you want a different sample rate, right now I have the slowest sample rate in interrupts. Thank you for watching. If you like this video, press like and share it with others who would need some help. In the next episode, I will show you how to configure an UART or USART communication protocol, and I will use it for establishing communication from my laptop inside a Bluetooth module. I will show you the Bluetooth module. It's this right here. That's how it looks like. So see you in the next episode. Goodbye.